Hello and welcome. In this video, we are going to be talking about a couple of key things that need to take place to ensure basically data integrity when setting up databases. The first one is normalization, and the second one we're going to talk about is the concept of keys, primary keys, unique keys, and foreign keys in particular. The topic of normalization and more about it can actually be read in our textbook starting on page 166, and it's like the whole first part of the chapter that we'll be covering this week. And the cool thing about it is this is something that can actually be done with pen and paper, to diagram it, to get a better idea about how we're going to do it, and we'll see some graphic examples as we move through. So what is normalization? Well, normalization is a process in which it ensures that each table in a database has only the minimal fields necessary to actually function. It removes what are referred to as dependencies, meaning that a table needs to have one thing in it that depends on another. The only dependency that we want to see is on the primary key, and we're going to talk about that. And it eliminates redundancies. And just for an example, think about if you have a database that is collecting contact information for individuals. So you have a first name, a last name, a street address, and the city, state, and zip code. Well, that city, state, and zip code, you might have several people within your database that have the same city, state, and zip code, and at the very least might have the same state. So that would be redundant to place it in the single table and use it over and over and over again, whereas it could actually just be pulling from a separate table that just has the states listed once. This leads us to an important piece of what are the benefits of normalization. I stated one of them is it reduces redundancies. So what it happens is it also happens to reduce the usage of storage space, on your database, on your server, by categorizing that data in a way that makes sense. It's done because now you have the data is stored a minimum amount of times instead of repeating it over and over again. Therefore, this also aids in better, faster, and stronger searches, since searches are based off of databases, as it entails fewer entities to scan. Are you sensing a trend? We're trying to keep the amount of data down, but we are going to be tying them together. And therefore, because, for example, going back to the example when I said states, well, say for the example of Wisconsin, you decide to type in WI one time. The next time you type in the full word. The next time you type in the four-letter abbreviation, WISC. Well, that's going to degrade that data integrity, because what if I do a search for Wisconsin and some of them don't come up because they don't quite match the search criteria even though they are Wisconsin? So by storing everything in the same table within our database one time and one way, it's going to improve our data integrity. Because we are keeping a minimum amount of data per table to make our database more streamlined, what we are doing is we are relating these tables to one another. This is referred to as a relational database. And the founder or inventor of relational databases is a man by the name of Edgar Frank Codd. And he worked for IBM for many years. And in a paper that he wrote called A Relational Model of Data for Large Shared Data Banks in 1970 is what changed the way we look at databases. He developed this process for normalization that we are going to go through that helps us streamline our databases. And according to Mike Hillier, I just thought this was a really good quote. You're going to see how this makes sense in just a few minutes. Is the goal of database normalization is to ensure that every non-key column in every table is directly dependent on the key. The whole key and nothing but the key. And with this goal come the benefits in the form of reduced redundancies, fewer anomalies, and improved efficiencies. Now, what this means is you're going to find out what a key is, and we're going to talk about the primary key, the item that needs to be dependent on, that items within a table cannot be dependent upon each other, and if they are, they need to be pulled out and put on a different table. And that's what we're going to go through in this process called normalization. There are 3 steps that we use when we are normalizing our data. The first is called the first normal form and is sometimes abbreviated 1NF. In this case, each column must contain only one value. Think, for example, in some of the early stuff that we were working on, we had first and last name in the same field. That would be a violation of this first normal form. It would not be compliant with that. And so sometimes that it's also referred to as atomic or indivisible. And you will see this in the book. Basically what that means is it cannot be broken down any further. So each column must contain only one value, and no table can have repeating groups of related data. I think the example the book uses, and it's a good one, is it's using the idea of a movie database or a movie table. It lists the name of the movie, and then it has in the columns after that, it has actor 1, actor 2, actor 3, actor 4. Well, those are repeating groups of related data. So that would be in violation of the first normal form. I know for those of you who are visual learners, hang on, because at the end of this, we're going to walk through how we actually go through and normalize our tables. The second normal form, or 2NF, says, first of all, the database must already be 1NF compliant, meaning you've already gone in and you have made sure that every column only can contain one value. Then, after that, this is where that quote that I shared with you is, every column that is not a key must be dependent upon the primary key. If it's dependent on anything else, it needs to be removed and put in a different table. I found this as a really good kind of hint, and it says you can normally identify a column that violates this rule when it has non-key values that are the same in multiple rows. A good example or good way to think about this is going back to the movie database that we talked about regarding the first normal form, is now say instead of the movie title and then we have all the actors, well, now what if we have a movie title and it has multiple genres, but those genres can be applied to multiple movies. So we might have Beauty and the Beast that is considered a drama, but we also have other movies that can be considered a drama. So we would probably put genre in its own table, because otherwise the table we have is going to keep repeating these values over and over again. So our third normal form is, first of all, it needs to be 2NF compliant. And of course, as we said, if it's 2NF compliant, it needs to be 1NF compliant. So that's the first part. And every non-key column is mutually independent. No non-key field, and that's what we're going to talk about, is what on earth are these keys that I keep referring to, depends upon another. Oftentimes what happens is if you follow the first 2 normalization steps, you may not even have any third normal form issues to even work out. So oftentimes those first 2 are going to take care of any normalization issues that you have in cleaning up a table. So what on earth are these keys that we're talking about? Because we keep saying everything has to be dependent or independent of these keys. So what does that mean? Well, there are 3 different types of keys that we are going to talk about in particular. There is more about indexes and keys in the textbook. There's also more about it in one of the readings that I'm sharing in Learn at UW Stout. Like I say, again, we're covering this very quickly, so we're not going to go in depth on anything, but the one of primary importance is the primary key. You actually already have done this. In the table that you set up last lab, you were asked to create an ID, and that was using a primary key. Now, a primary key, there can only be one primary key per table. And so this is in the column that you set up, and it's oftentimes labeled as ID, or it includes some idea of what the table name is and ID. In some database management systems, primary keys cannot be null. I haven't actually checked to see if the particular table and database schema that we're using allows for primary keys to be null, but that's how we're going to treat them. And that's why even in the lab that we did last week, I had you set it up as something that could not be null. That was one of the checkboxes that you indicated when you set up the table. And a way of thinking about a primary key is it's a unique identifier of the record. A really good example in our day-to-day lives is any sort of ID that you have. Think your social security number. Think about your student ID number. Nobody else has that. It was set up to identify you and only you. That's really what a primary key is doing in our tables, is it is associated with one and only one record. So then we have this thing called a unique key. And a unique key, there can be more than one in a table. They can often have null values. And the reason that it can have null values and that there can be more than one in a table is it does not have to be the primary key. And a lot of times where we see these unique keys is when we're setting up relational databases and we are pulling in what is referred to as a foreign key. And a foreign key is a field or set of fields in a table that uniquely identifies a row from another table. And so oftentimes that will be the foreign key is the primary key from another table, making it a unique key in the table that you're on. The table in which a foreign key is defined is called the child table, and here it is, it often refers to the primary key in the parent table. Okay, so are you thoroughly confused yet? Let's test it out and look at some visuals, okay? This will help, I think, tremendously.